Okay, so here we're going to use Euclid's algorithm to calculate some greatest common divisors. And Euclid's algorithm is based on the following fact. That the GCD of A and B, if we can write that A is equal to quotient times B plus remainder, then the GCD of A and B, where A is greater than B, is the GCD of B, which is the smaller of the two, and the remainder of dividing A by B. This is the remainder after we divide A by B. A by B. And I get a quotient, and I get a remainder. Okay? And what we're going to do is apply this successively, because each time we take a GCD, we end up with the GCD of smaller number, the smaller of the two, plus just that remainder. And so I'll apply this, and we're going to put these numbers into a little table. For part A, I'm going to go 1620 and 1545. I'm going to put them in a little table like this that allows me to put quotients and remainders. And I'm going to go ahead and put the quotient here and the remainder here. And the quotient, after I divide 1545 into 1620, remember we're going to divide the smaller one into the larger one. Or we're going to divide 1620 by 1545, however you want to say it, is the quotient is 1, and the remainder is 75. Okay, and now I'm working with the two numbers 1545 and 75. There's the smaller of the two plus the remainder. Okay, the smaller of the two, the B, and the remainder is what I'm working with now. And 75 goes into 1545. Oh, I don't know, 20 times it goes into 1500, so just 20. It goes into 1500 with a remainder of 45. Right? Yeah. 75 times 2 is 150, so times 20 is 1500, and then we get a remainder of 45. 45 goes into 75 once with a remainder of 30. 30 goes into 45 once with a remainder of 15, and finally 15 goes into 30 twice with the remainder of 0. And the rule here is that as soon as you get the 0, you know that the number above it is the GCD. So the GCD is 15. Okay? And we're going to do that for all of them. And remember, you're going to put the quotient and remainder in sort of a diagonal. You're going to take these two guys and put the quotient and the remainder in sort of the diagonal there. Let's do 1080 and 504. We'll make a little chart. .1080, put the largest here, and 504, the smaller there. And if I double that, I get 1008, so twice with a remainder of 72. 72 goes into 504. 6 times 7, 7 times 7. I think 6 times 72 will be my number. 72 times 6 is 12. Sometimes 42, 43, 432 plus another 72 is a 405. Hey, it goes right in. It went in exactly 7 times. 490 plus 14, yeah, 7, 0. So now we have our GCD is 72. GCD of 1080 and 504 is 72. Finally, part B and C, or part C and D. Here we have 5, 12, and 46. I may be running out of space here. 5, 12, and 46. And 46 goes into 512. It goes 10 times into 460. 11 times into 506. So it's 11 times with the remainder of 6, because 512 minus 506. 6 goes into 46 7 times. 6 times 7 is 42. 46 minus 42 is a remainder of 4. 4 goes into 6 once with the remainder of 2. 2 goes into 4 twice with the remainder of 0. And the GCD is the number right above the 0, which is 82. Okay. Sorry for the crunched up solution there. Part D. Boy, I really need more room, don't I? I'm going to go ahead and take some room down here. As a matter of fact, I'm going to write 5, 12, 46, and spread my work out on this other one. I got 11 and 6. I got 7 and 4. I got 1 and 2. I got 2 and 0. And there's my GCD. For the part D, I've got 2100 and 120. 2100 and 120. And 120 goes into 2100. Well, it goes into 2400 20 times. So I think 18 times it'll go into 2100. 120 times 18 gives me the 0, 6, 90, 960, 0, 2, 1, 60, 11, 2160. Really, it's 2160? Yeah, it can only go 17 times. So if I subtract 120 from that, it's 2040. Okay, so 17 times. Doesn't matter what the quotients are, so long as we get the remainder correct. 17 times is 2040, so it leaves a remainder of 60. 60 goes in 120 twice, and so 60 is my GCD. Okay, there's number 3. Hope that helps.